The topic is the penetration testing of the vehicle components like ECU and the fleet management systems. So I'm Arun Mane. I'm the founder and director of the INFOSEC Labs LLP. That particular focused on the components, the services like hardware testing, industrial control systems, vehicle and telco products as well. So my interest lies in those field, and I'm the speaker and trainer of different conferences like DEFCON and DefCamp as well. Let's start the presentation. So this is the definition for those people who don't know the car actually. So it's for more than three, or rather you can say more than two wheels. They call it as a car, and they transport one people to another, one location to another location, and that you can find on Wikipedia as well. So if we talk about the modern car, so you will find a lot of components over here, like the Bluetooth, Wi-Fi, telematic devices, even key fobs, key entry you can say, with key fobs or keyless entry. In that case, we have OBD2 TPMS, tire pressure monitoring systems, and body controller module, or rather you can say engine control unit, electronic control unit. Those components you can see in the modern car. So what exactly the CAN? CAN is nothing but a controller area network. So it's modern the communication protocol for used in vehicles, or rather you can say the transportation. So it's a two-wire protocol, so CAN high and CAN low, and it uses differential signaling. So 1987, the Bosch was the company who introduced the CAN bus protocol, and it has two type of protocols like CAN 1.0 and 2.0, and again 2.0 has two parts, A and B. So its difference between the A and B is like identifier bit. It's a 11-bit and a 29-bit. So what we are targeting over here is we talk about the physical testing of the car, or rather you can say the ECU. So sorry about that. So OBD2 is an onboard diagnostic port, you can say. Here, if I talk about the OBD2, it's like in US it's mandated in 2004. Every car, in 1999 every car should have the OBD port. So first they introduce obviously the OBD1, then they come up with the OBD2. If I talk about the European standards, they call it as the OBD. So that specifies the architecture of the, not exactly the pin description of the OBD2. And here you can see 6 and 14 as used for the CAN low and CAN high. And you can see over here like 5 and 4 are the signal ground and the chassis ground. So whenever we talk about the CAN bus, or rather OBD2, it always works on 12 voltages. So where you can find OBD2 ports, like if I talk about the car, so there are different places you can find the OBD2 ports, like it's nearby the driver's seat, or maybe on the rear seat as well. Backside also. So mine car is like electric car in India. So I have OBD2 port on backside at the backside, and the one OBD2 port is on the rear seat of the driver. So there are different cases you will find those structures in white, sometimes in the black. So sometimes you come up with the female OBD2 or male OBD2 depending on the manufacturers. Sometimes you'll see those kind of OBD2 as well. So in that case, you need to have some sort of the converter. So in that case, if you talk about the USB or other DB9 cable, so you need to have DB9 to OBD2 converter. In that case, you will have this specifically. I believe it's from the Mercedes. So if you open any ECU or other engine, so you might find those kind of the structure or the port where you need to find out the USB DB9 to this kind of pin numbers. So that particular pin numbers are described like 4 and 5 is like ground, and other 14 and 6 is for CAN high and CAN low. So how the ECU looks like? It's a kind of embedded systems. So they use the microcontroller instead of the microprocessor. So microprocessor, I can give you the example of Raspberry Pi. It's a microprocessor, right? So you can install Linux, Raspbian OS, right? But in ECU, it won't be possible. It's pure microcontroller. And if you compare the entire coding, the skeleton, or rather the number of lines of codes with respect to the Facebook and other social network, it's a huge. If I compare with a modern car, so it's very huge. It's billions lines of codes in the modern car. So if you compare with the Facebook, it's very less. The lines of codes of Facebook is very less than the modern car. So in that case, all structures or other codes it's in C language, and it supports a lot of microcontrollers which flash the entire code inside. So if you see, there are a lot of capacitors, some crystals over here. So it's pure embedded systems. So we'll come to the hardware part as well, how these things are vulnerable for hardware attacks as well. So this is how when you see the internal parts of modern cars. So every devices has features has some sort of the ECU. We call it as a electronic control unit. So nothing but this thing. So very small. It's depend on the size. It's depend on the size of what exactly the device inside the car. So in the modern car, you will see more than it's minimum like more than 200 ECUs in the car. So if you snip the entire communication in the car itself, you'll get a lot of communication while you're snipping the entire communication. So these are some features for the modern car, like every seat controls, infotainment systems, then emergency brake systems, and ventilations, HVAC, everything has some sort of embedded system we call it as ECU. So every ECU has some sort of the functions, or rather you can say event to perform. So again, the control unit, as I said. So what about the protocol, different kind of protocols? So you will see, so if I distinguish these protocol as per the requirement, as per the data rate. So it's a LIN protocol, it's a one-wire protocol, so where the data rate is very slow, and if you see the requirement is very low actually. And if I compare with the CAN bus has a huge demand in the in the market as well. So the data rate would be the highest. So if I sorry, if I talk about the FlexRay, now the FlexRay is getting outdated, but the speed of the FlexRay is very higher than the CAN bus, but the requirement also it's get increased. So as I said, the CAN bus is the two-wire communication, CAN high and CAN low, and it uses differential signaling. So if you see the differential signaling over here, CAN high, CAN low, but it has some sort of the packet frames. So arbitration ID here is so important in that case when you trying to do pen testing, or rather you can say some sort of attacks on the ECU or other in the car itself physically. So it's a DLC, and then data, and then CRC, and end of the frame. So if I see the CAN network, So on the single bus, we cannot say the single bus actually. So in the main bus, you will see a lot of components are attached, like ECU lamps, headlamp ECU, then lights ECU. These are the different kind of ECUs connect with each other. So what's the how it communicates? It only broadcasts the message. So if it is broadcasting the message, so what exactly? How they identify, or rather you can say, if they broadcast at the same time, which one will be the highest priority message? So it's depend on the arbitration ID. So if the arbitration ID is low, then the message would be would have the highest priority on the CAN message. So let's say the brake has the arbitration ID very low because it's emergency. At the emergency, we push the brake, and that's executes mechanically with the help of ECU, right? So in that case, the arbitration ID of the brake would be always be less than other messages because it dominates that arbitration ID to other CAN messages. So here, in that case, if you want to do some sort of reverse engineering of particular event like a brake, headlamp, or other you can say side indicator, a lot of things, or other you can say RPM. So we need to find out what kind of the arbitration ID in that case. So in a CAN transmission, if I say the ECU 1 and ECU 2 and ECU 3, so these are the messages, let's say 3 and 3. So it would be 1 second, 50 seconds, and 250 seconds. So it's the time difference between two consecutive messages. So it's very important we need to find out the message, the time difference between the two messages for particular thing. So it's depend on the what kind of message it is. If it is brake, so time travel or other time difference between the two consecutive messages would be a very less because it's faster than the other messages as well. So what are the extended protocols for the CAN bus? These are the protocol like ISO-TP protocol, CAN Open, GM-LAN, SEG 1850, PWM. See, these are the different kind of protocols which is based on the CAN bus and which can be the extended. So depending on if I talk about the GM-LAN, it's a General Motor LAN. So it's Ethernet-based protocol as well. So, if we compare the entire protocol with the OBD2 ports, so here see as I said, the 6 and 14 number is for the pin number is for the CAN bus, CAN high and CAN low, and KWP L-LIN, and the other PWM and MS CAN. These are the pin numbers for the different messages. So what are the tools you can see in the while doing some sort of testing? So there are some commercial tools are available. Here I listed few of them commercial tools, not few and only single. So ValueCAN 3 is one of the good tool you can say in the market. So there are some tools like Vectors, Canopy. There are some Optilizer from the Germany. They are tools in very expensive. This tool is cost around the $390 or $400, and the software cost around maybe from $150 to $4,000, $100 to $4,000, $1,000 to $4,000. So if I talk about the software, it's really costlier than the hardware itself. So there is an open source tool called as USBTIN. So here we are doing the car hacking village over here. So you can see these kind of tool in car hacking village, and you can see the live demo of how we can do some sort of the CAN bus testing and the how we can crack the seed keys or the ECU as well. So USBTIN supports only CAN bus message, not the LIN protocol. And this is the same thing inside they use Microchip. Even the CAN USBTIN uses Microchip the chipset. Even in this tool also they use Microchip, and This can used with the help of CAN socket, right? CAN util is one of the library in the, you can find it on Linux. So if you install CAN utils, you'll definitely attached with these things. It has a TTL to USB converter, so you can connect with the Linux and you can start sniffing those communications as well. So this is one of the cool tool. It's called as CAN Badger. So these guys are the creator of the CAN Badger. One is Ferdi and he's the Javier as well. So these guys are very genius. I follow them actually personally. So they're a good researcher and they made this CAN Badger. It has 2 DB9 cables and the Ethernet as well. So they made the client software. It's same like a burp suit, so you can intercept the communication, you can change the communication and send it to the ECU or other car. So it's like you can see their talks in Hardware I/O 2016. They call it as a car hacking like a burp suit. So if you see these things, it's really amazing. Then you can send UDIS packets, ISOTP packets, and a ton of things you can do. And if you search for the CAN Badger on the GitHub, you'll see the bomb. So within $125, you can make those devices. And now they are coming with a pro version. I believe within 5 months they're going to release that CAN Badger Pro. But it's really cool. CAN Tools is one of the software, so even the USB tin and other software can work with this CAN Tools. Is from the Russian guy. For LIN as of now, we can see the Microchip LIN as analyzer. So Microchip gives the Windows-based the software. From there, you can analyze the LIN protocol, and you can send it and receive it, those kind of protocols as well. But there are some protocols, like there are some tools, commercial tools available in the market, like Optilizer or other, you can say the Vector as well. So what kind of attacks you can perform on the CAN bus? We can perform the DOS attack. It's nothing but if I like here in OBD2, if I short this thing with CAN and CAN low, it becomes DOS again. It's like a physical. But what you can do with on the over the packet is itself. So in the over the packet, it's like if you send the 000 the message on particular ID, and that can cause the denial of service attack on the particular the CAN bus. Firehose again. So as I said in the firehose. So this speed is very critical, right? So let's say we have 500 milliseconds. One ECU transmits those messages with the 500 milliseconds. So what happens if you send same thing, that message with the 500 millisecond? So it would be same, right? So there is no effect on the on particular ECU. So we need to reduce these things. We can reduce 1 millisecond, 10 millisecond. So our message goes first on the particular ECU, and you can see the effect on this. Called as firehose attack. Firehose, that means it's related to our the transaction. So packet payload modification. So you can modify the payload. So you can inject some sort of other packets as well, which can, it may be UDS, it may be anything. Like if you know the ID, and if you know the ID is responsible for reset ECU or other, you can talk to ECU to dump entire the information about the firmware, or you can dump the firmware over the ID. So that thing you can do with the packet payloads modification. Packet replay. So again, it's the same. You can record the entire session and you can replay it. There would be possibility that that can be a replay attack. Right after, right before is kind of the attack where if you have the malicious packet first, and then you're sending legitimate packets, there is a possibility that FIFO and LIFO it's happening on the microcontroller, that triggers a buffer overflow attack, on the ECU itself. The same thing if you send the legitimate packets first, then the malicious packet after that, there is again a possibility you can trigger the buffer overflow attack on the particular ECU. So for that purpose, you can come to our the car hacking village, and we'll see the live demo that how we can do seed key or other seed key cracking, or other you can say the other DOS attack and fire hose attack on the speedometer itself. So now it's FMS, it's a fleet management systems. So if you see over here, the fleet management systems over here, it's connected with a lot of communications. It supports the GPS locations, and it supports GPRS and GSM, 3G, 4G, depending on the what kind of the fleet management uses the communication, and that's connect to the tracking server. It's nothing but the manufacturer or other any vendor. Which gives the service of fleet management system, and from the client PC or other mobile, you can track the entire communication. What exactly the USP over here? The location. So location is the main critical over here, because you have to understand, or rather, we have to see where exactly my the vehicle is going in which direction. So for that purpose, they use fleet management systems. So what are different kind of attacks you can perform? So fleet management systems like a OBD2 dongle or other any kind of TCU, they call it as a transmission control unit or other telematic control unit that resides in the car network, and from there they connect with the GPS, and from the GPS to GSM to the cloud, and cloud to your PC or other mobile. And that supports GPS as well. So when we are doing some sort of hardware testing, so we found some the double EEPROM, that SPI flash. So we could not find any protocol over the GPS, though I can do some sort of the GSM jamming, or other you can say I can make the fake GPS, fake BTS, and that fleet management system can connect with my fake BTS, and I can intercept, and I can try to inject some SMS if it is supports SMS, or other any CAN message on the BTS through the BTS itself. So what we found the SPI chipset, and we have the programmer, that is CH341A programmer, and we connect with the SPI chipset, and we extracted, and we found this information from these things. We found here is the IP address, here is some company's link, and company link, and here's some IP addresses which is hard-coded inside the SPI ROM. And these are some phone numbers. These are the phone numbers when they use the fleet management system and they register the mobile number. So you will find those mobile numbers here. So this is again one kind of vulnerability, you can say. And this is the serial numbers. So when we scan this IP address, so with the help of Nmap, we found this FTP server is running on particular thing. And we found all the bin files, that is firmwares, right? So these are the firmwares which is used for the fleet management systems. And what happened when we extracted those firmwares and we done reverse engineering, so we found some sort of passwords over here. So username, password for a particular link. So I cannot show that links actually, but this is how we found a very juicy part, and we try to control that particular devices. And we can easily locate where exactly the other devices, registered devices on in the fleet management systems. So then we done some GPS spoofing. So we have the HackRF, and we have GSM antenna, the rather GPS antenna. So initially, this this address is from the Pune, India actually. So we are driving the car with the fleet management system. So initially we were here, then we move further. So we spotted over here, then our car is here, and you can see we are moving around. And when we start GSM spoofing, this is one of the very good tool, GPS SDR SIM. Is one of the Japanese guy who created this software. Very nice. You can use the software, but it's depend on you actually. So how can you use that and how you can use for malicious things. So what we do, we mention our coordinates with the GPS SIM bin. So that particular bin file has the coordinates, and with the help of HackRF and the GSM antenna, we executed this data, GSM's GPS SIM data, and what found? Our car is in New York, right? So we were in India after spoofing the coordinates. Our car is in New York, USA, and we are driving the car, and you can see the car is moving from one location to another location. So this is another kind of vulnerability with the GPS. Still, we are figuring out what the solution it is. Like if it is GSM spoofing, if you want to avoid the GSM spoofing, and even the device is very small, so there are some techniques to do that. But if someone has a solution, you can talk. We can discuss after the talk actually. So how we can mitigate this GSM spoofing. So how this is, it's very critical because it's a USB for those people who makes the fleet management systems. What happened? Your car is get stolen, and yours try to see where exactly your car, and someone is from the very genius robber, or rather you can say the thief. He can do some GPS spoofing, and your cars can put instead of Romania, it can put in India or somewhere else, and you cannot locate exactly the car where it is. So this was the vulnerabilities we found in the fleet management systems and everything. So, any questions? Yes.
Hello, Arun. Thank you very much for the nice presentation. I have a question. Do you know when the CAN has started to be encrypted? The year?
Sorry?
The CAN.
CAN message.
CAN, yeah. When they started to implement encryption on the CAN?
When
they started
encryption.
Encryption. Which year they start, the car makers?
Encryption. So I don't believe actually. So
I
don't have knowledge.
On the CAN?
So there is no encryption, but there are some things you can implement. The gateways, they call it as a gateway. Like in the IT sector, we use firewall, right? So in that case, they can use the gateways. It acts as a firewall. They can use switch between the ECU and your sensors as well. So it's depend on how the big how your the architecture of your car, and based on the architecture and based on the safety security standards and the cyber security standards. When you implement some sort of cyber security solution, you have to take care of the safety standard as well. Sometimes what happen, there would be a delay in the message over the ECU, so that can hamper the safety security as well. So according to we call it as a TARA, and they call it as a HARA. So TARA and HARA, we need to match those things, the threats, and we need to come in a particular stage where are we able to use any critical solutions like the gateways or a firewall in that case, and on which protocol, on which device, or rather you can say which feature. That's the thing actually.
Okay, thank you, Arun.
Thank you.
Arun, we have another question here.
You can start the engine of unlock the car if I have connected the OBD2 dongle?
Yes. So in this example, that only reads the message, not writing any message on the OBD2. So if it is reading message, like you need to check first whether your FMS, like fleet management system, is able to start your engine or not. If it is, if that fleet management system has those kind of features, yes, definitely. So if you can hack, or rather you have access on the cloud and you know the particular FMS, the device, you can send those message to that FMS, and from the FMS that can message sent to that particular over the OBD2. That can be possible. Or rather if you do some sort of reverse engineering first of the car, what the message is responsible for to start engine, off engine, opening door, and that particular message you can inject through the FMS or the GSM or the 3G or 4G. So you need to make some sort of the fake E node. If I talk about the 4G, if it is 2G, you need to create a fake BTS in that case.
Thank you.
Yeah.
Okay, folks, we will take one more question.
Yes.
Okay.
Hi. Very great presentation. But my question is, as a simple driver, I can protect myself from some attacker or something like that? So I don't know all this kind of stuff.
That's really
Security.
interesting question, actually. It's the user standpoint of view, actually. So there are a lot of possibilities that nowadays a lot of the technologists talking about the ADS, anomaly detection systems. So that thing can be possible, and if it is, there would be possibility that some people, some researchers are working on the prevention system as well. Some incident occurs, they can kill the CAN bus message, but it's not exactly the word. I cannot use that particular word, but in layman language, yeah, it can kill the CAN bus message. So there would be in future there a lot of possibility that things the ADS or the prevention system can implement in the ECU, and that ECU is itself sufficient, like it detects automatically and it kills that particular message. So still we are also on the phase of research, actually. We made ADS, but we are in the phase of the prevention system as well. Thank you.
Can I get one more question?
Yes.
You have to have physical access to the car, yes?
Yes, for reverse
anything
engineering.
you want to do, yeah? If the car is locked and you don't have physical access to the OBD2 connector, you can hack the car, yes or no?
Yeah, so
This is the question.
so there is a different ways to open the car, actually. So you can do some sort of replay attack on the key fobs, or the relay attack on the wireless key. That would be the possibility.
I know, but forget about the key and to unlock the car.
Yeah, it won't be possible. Yeah,
okay.
It won't be possible. But yes, anyhow, if you open the bonnet, there is a possibility you can connect directly to the ECU, and that you can.
Yeah, I know, but you have to have physical access to the OBD2.
Yes,
Okay.
yes. But this thing is the penetration testing point of view, that talk is it is. So it's not like, but if you have access, you don't need to OBD2 as well. You can just do some sort of the short circuit, some wires, and you can start the car and go away, right?
You can, because it has a electronic immobilizer, so
Yes,
you have
yes.
to bypass that.
Yes, that would be possible. Thank
It's nothing like the movies. So.
Yes.
Okay, thank you so much, Arun.
Thank you very much.